Mr. Rops here.
And Mr. Cole.
And we're going to do another justifying by algebraic means. This is the second method, another way to do it. As the patterns get more complicated, there oftentimes there's lots and lots of ways to consider it. So we know we have to do it by pattern first. And we have our table, and I know this is a difference of 4, a difference of 6, a difference of 8, and so we had a second differences of 2. Okay? If I extend my table, I get k here.
So we've already got the formula for this,
Right.
we're trying to...
Right, the formula we know was that one.
Yep.
And so the number of dots would be k squared plus k.
Right.
Now,
The tricky part is trying to figure out what we need to add to that to get the k add 1 when f is k add 1, right?
each time we added 4 and 6 and 8, and what are we going to add in terms of k for this one?
Okay. I would make maybe another table with just f and that second difference, perhaps.
Okay, so f
Sorry, and the first difference.
and the first
What can we call it?
first difference.
Okay, so the first, and f is 1, 2, 3. We get the first difference of 4, first difference of 6, 8.
And then this
And
one
then
was 10.
Would be 10. Okay, so that's a linear sequence.
We can see
It
that
goes up in twos, like the 2 times table. So it's going to be like 2 times f. But that just gets us to...
So if I now say that this is 2 times f, this is 2f, I get 2, 4, 6, and 8. So 2 times 4, 2 times 3, 2 times 4.
And so what do we have to do to 2f to get our first differences? It looks like it's just 2 bigger. So we have to add 2 to our difference to get...
So 4 plus 2 will get 6.
Yep.
6 plus 2 will get 8. 8 plus 2 will get 10. That looks like there's the pattern.
Okay, so we've got 2f add 2.
2f add 2. This is what we add each time to, in this column here, each time we add 2f plus 2. That's how many dots we add.
Yep.
So that means if we're on the kth term, if we want to go now to the k plus 1 term, to go to k plus 1, we are going to add 2k plus 2.
Yep.
Well,
So what do we end up with?
we have k squared plus k plus a 2k plus 2.
Which is...
K squared plus 3k plus 2. This is by pattern. I know I have to also do it by formula. Well, here's our formula. And I let f be k plus 1.
Yep.
So d is k plus 1 squared plus k.
K plus 1, yep.
K plus 1. Excuse me. And now, if I expand this out, k plus 1 plus a k plus 1. First terms are k squared. No, that's mixed.
So we've got outside would be k, add k. Inside would be add k. Out, and then last would be 1 times 1 is 1. And then we've still got our k add 1 at the end. If we collect like terms here, we're going to get k squared, add 3k, add 2. Which is the same as the one that we found by pattern. So we know that we have justified our formula.
Hooray.
Nice.
So in doing this one, we found a pattern on the first differences.
Yeah.
Super.